Chapter 0, exam review. Most of you can pretty much handle these linear ones, but I'll walk you through this one. The first thing we'll want to do is distribute the -2. Get all the variables on one side, the constants on the other. I think I'll send the variables to the left and the constant to the right. Combine all the like terms and then divide by the coefficient. N is 2. Absolute value equations and inequalities later, we want to make sure we isolate the absolute value expression first. So move the 10 over. This expression says distance from 0 is 3. Absolute value means distance from 0. So we can say that that expression, 5n plus 3, can be at 3, or 5n plus 3 could be at -3. That's the distance from 0. Solve each of these. 5n equal 0, n equals 0, or 5n equal -6, n equal -6/5. This linear inequality can be expressed as really two inequalities. We've got this one, -16 is less than or equal to 2n minus 10, and we've got this one, and the word and in this combined, it's a conjunction. 2n minus 10 is less than -8. We could solve each of those with the and, the conjunction. First one, we simply add 10 to both sides to isolate the variable, and divide by 2. And then I like to read these with the variable on the left. This would say n is greater than or equal to -3. For the blue one, we would add 10 to both sides. That would be 2, and divide by 2. So n is less than 1. So I want all numbers that are greater than -3 and less than 1. It's useful to see that on a number line. Here's -3. I want greater than or equal to that, and at the same time, less than 1. So the numbers that satisfy both of those are the numbers between -3 and 1. The -3 is included because it's shaded, and the 1 is not. So that's an interval notation for the solution set. 4 is a disjunction. We have this inequality or this one. So the or means as long as it satisfies one or the other, it's in the solution. To solve the red one, we would subtract 5m from both sides, and then subtract 2 from both sides on all numbers less than 3. The blue one would add m to both sides. M, subtract 6, and divide by 6. -2 is greater than m, or m is less than -2. Okay, let's put them on a number line. I want all numbers less than -2. That's an open circle here, going that way. Or all numbers less than 3. That's open circle, less than, going that way. So when it's an or statement, as long as it satisfies at least one of these, it's in the solution. So if it's shaded at all, it's in the solution. In this case, we want from -infinity to 3. Open. That's it. These absolute value inequalities, it's best to remember that absolute value means distance from 0. Distance from 0 greater than some number would mean if this is 0 and this is 20, this expression would be greater than 20 or less than -20. So we say we take that expression, 2 plus 6p and say that could be greater than 20 or could be less than negative 20, and solve each of those. Subtract 2 from both sides, divide by 6. Subtract 2 from both sides on this one. That should be a 6p. Divide by 6. Negative 22/6 is the same as negative 11/3. Okay. So on a number line, p would be less than negative 11/3, those numbers, or greater than 3. Our solution, that we say, would be negative infinity to negative 11/3 union 3 to positive infinity. An absolute value expression less than a number is a conjunction. Conjunction. We use the word and. Okay, so distance from 0 is less than 26. Means I need less than or equal to, and I need those numbers, and distance from 0, 26 could be those. Okay, so it's going to be less than 26 and greater than negative 26. That's how we set that up. Take the expression 3k minus 5 and make that less than or equal to 26, and the 3k minus 5 is greater than or equal to negative 26. And solve each of those. Add 5 to both sides. That's 31. Divide by 3. 31/3. Over here, we add 5. Divide by 3. And put that on a number line. Okay. I got negative 7 and 31/3. I want the numbers greater than, excuse me, less than or equal to 31/3 and greater than or equal to negative 7. The numbers that satisfy both situations is the numbers between negative 7 and 31/3. The ones that are shaded twice include those endpoints. Or system by substitution, we isolate one of the variables. So we can take this one and isolate x. X is equal to negative 3y minus 2. Since x is defined this way, we can substitute this expression in for x in the second equation. The second equation says 4 times x, but x is negative 3y minus 2 minus y equal 18. And that's a new linear equation in one variable. Distribute the 4, and we combine like terms. Move the 8 to the other side, and isolate y, dividing by negative 13, and y is 2. Excuse me, that'd be negative 2. And we could plug that back in for y in the original and solve that for x. Negative 3 times negative 2 minus 2 more. That's 6 minus 2, that's 4. X equals 4. This means that these two lines, this one and this one, are consistent, independent, and they intersect at the point 4, negative 2. Solving by elimination, we try to get opposite coefficients in a single variable. So let's go for maybe x. If I multiply the top equation by negative 3 and the bottom equation times 4, our coefficient in x would be negative 12x and positive 12x. Opposites, that's what we want. So distribute the negative 3 to the first equation and the 4 to the second equation. This is the equivalent system after I've multiplied by those constants. So if I add equals to equals, I'm going to have equality maintained. The x's, negative 12x and 12x, add to 0. That's eliminated. The y's would be negative 7y, and the constant would be negative 7. So y equal 1. You can now plug that back into any of the two equations above. Let's plug it into the top one. We get 4x minus 3 times 1 equal 5. So if I add 3 to both sides, 4x equal 8. So x equal 2. This one is also consistent, independent, and the solution is 2, 1. One of these word problems, we want to read through it, make sure we understand what it's asking us. Okay, we got two schools that are going on a field trip. They're taking vans and buses, high school A and high school B. So we're going to want to know how many students can a van carry and assign a variable. Let's let V be number of students per van. And I guess B can be the number of students per bus. In this expression, school A filled 2 vans and 3 buses with 111 students. The equation could be 2V, 2 vans times the number of students per van, plus 3B, the number of students per bus, is there 111 students. The second sentence, school B rented and filled 5 vans and 2 buses. So school B has got 5V plus 2B is 107 students. That gives us our two equations that we can solve in the system. We can do it either way that we already have, elimination or substitution. I suggest elimination. We can eliminate the vans. So we want to find out how many students a van can carry. So why don't we eliminate B? We can multiply the second equation times -3 and the first equation times +2. So we get these two equivalent equations by distributing the 2 in the red equation and the -3 in the green equation, so that when we add these together, we will eliminate B. +6B and -6B is 0. We add the first term, 4V and -15 would be -11V. And the constants, when I add those together, it's -99. So V equal +9. Number of buses a van can carry. Van carries 11 students. And that's it for this page. Let me know if you have any questions.